late at night, when everything is quiet and the world feels still, a simple question can begin to take shape in your mind. Could someone or something be watching us right now? Not in a frightening way, not like a movie, but in a distant, quiet, almost curious way. The kind of watching that doesn't disturb anything, just observes. And then another thought follows. What does it actually mean to be watched from space? We often imagine it in a very human way. Eyes looking down, maybe a spaceship hovering somewhere above the clouds, but space doesn't really work like that. It's far too large, far too empty, and far too quiet for anything that simple. So if an alien civilization were watching us, how would they even do it? Would they see people walking down the street, cars moving through cities, lights turning on and off at night? Or would it be something much more subtle, much more distant? To understand this, it helps to think about how we observe things here on Earth. Imagine standing on top of a tall building, looking down at a city. You don't see every detail. You don't see individual conversations, but you can still understand what's happening. You see patterns, movement, light, behavior. Now imagine stepping even farther away. Picture looking at Earth from the distance of the moon. At that point, the entire planet becomes something you can hold in your view all at once, like a glowing marble floating in darkness. You can see clouds swirling, oceans shining, continents slowly turning. But you can't see people anymore. So then, if something were watching us from even farther away than that, what would they actually see? This is where the question becomes deeper, because watching doesn't always mean seeing clearly. It doesn't always mean detail. Sometimes it just means collecting information, piece by piece, over time. In fact, you don't need eyes at all to watch something. You can listen, you can measure, you can detect. Think about how we study distant planets today. We don't fly there. We don't land on them. We don't send cameras close enough to see their surface in detail. And yet, we still learn about them. We can tell if a planet has an atmosphere. We can guess its temperature. Sometimes, we can even detect chemicals in its air. So now the question shifts again. If we can do that, what could a much more advanced civilization do? Could they be watching us in ways we don't even recognize? Ways that don't involve ships or lights or anything visible at all. It's possible that watching Earth might look nothing like what we imagine. It might not involve looking at people or cities. It might not involve being close to us at all. Instead, it might be something more like studying a signal, like tuning into a distant radio station, or reading faint traces of information carried through space. And that leads to another quiet realization. We might already be visible without even knowing it, because Earth is not silent. Even when everything feels calm and quiet here, our planet is constantly sending out tiny signs of life, signals, light, energy, patterns. It's a bit like sitting in a dark room with a small glowing screen in front of you. From across the room, someone might not see your face clearly, but they would definitely notice the light. And Earth, in its own way, glows. So then, what does it mean for someone to be watching us? It might mean they've noticed that glow. It might mean they've detected something unusual about our planet. Or it might mean they've simply become aware that something is happening here, even if they don't fully understand what it is yet. And that idea brings up a gentle but fascinating question. If someone out there noticed Earth, would they even recognize us as intelligent? Or would we just look like another active planet, full of movement and change, but without any clear sign of who or what we are? After all, if you were looking at Earth from very far away, you wouldn't immediately see humans. You would see oceans shifting like slow waves of blue glass. You would see clouds forming and fading, like breath on a mirror. You would see the planet rotating, day turning into night in a steady rhythm, and maybe, just maybe, you would notice something slightly unusual about it, something that doesn't quite match the natural patterns of other planets. But would that be enough to say, someone is there, or would it just raise a quiet curiosity? And then another question appears. If they are watching, why? Is it curiosity? Is it study? Is it caution? Or is it something we don't even have a word for yet? Because when we imagine being watched, we often imagine intention, a purpose, a reason. But what if there isn't one? At least not in the way we understand it. What if it's simply observation? The same way we observe things we don't fully understand yet. The same way we look up at the night sky, wondering what's out there. It's interesting, isn't it? We spend so much time asking if we are alone, but we rarely stop to ask what it would actually feel like if we weren't. Not in a dramatic way, not in a sudden, world-changing moment, but in a quiet, almost invisible way. The kind of presence you wouldn't notice unless you really thought about it. And maybe that's what makes this question so powerful. Not the idea of aliens arriving or making contact, but the possibility that awareness might already exist, somewhere pointed gently in our direction, watching, not with eyes, but with something far more distant and far more patient. And as that thought settles in, another one slowly follows. If someone were watching us right now, would we even know? As we move forward, feel free to share where you're listening from, or leave a quick thought below. And if this channel means something to you, subscribing is a small way to support the journey. If the idea of being watched begins to feel possible, even in a quiet and distant way, the next question almost asks itself, how easy is it to notice Earth at all? After all, space is not just big, it's unimaginably vast. The distance between stars is so wide that even light, which travels faster than anything we know, takes years just to cross it. So in all that darkness, does our planet stand out? Or are we just another small, quiet world drifting unnoticed? At first, it might seem like Earth would be hard to find. Compared to stars, planets don't shine very brightly. A star is like a giant spotlight, while a planet is more like a tiny mirror reflecting that light. Imagine standing in a dark field at night. In the distance, there's a powerful floodlight. That's the star. Now somewhere near that light, there's a small glass marble reflecting a faint glow. That's the planet. From far away, the floodlight is easy to see, but the marble, you would have to look very carefully. So then, would Earth just blend in like that? Not exactly. Because Earth doesn't just reflect light, it also changes it. And that small detail makes a big difference. When light from the sun hits our planet, it doesn't bounce back in a simple, clean way. It passes through clouds, reflects off oceans, gets absorbed by forests, and scatters in the atmosphere. Each of these things leaves a kind of fingerprint on the light, and that fingerprint carries information. It's a bit like shining a flashlight through colored glass. The light that comes out the other side isn't the same anymore. It carries the color, the texture, the structure of whatever it passed through. So if someone very far away had the right tools, they wouldn't just see Earth as a tiny dot. They might be able to study that light. And by studying it, they could begin to understand what kind of planet this is. So what would they notice first? They might notice the color. Earth has a very distinct look. Deep blue oceans, white clouds, hints of green and brown from land. Compared to many other planets, this combination is quite unusual, but color alone isn't enough. So the question becomes, could they tell that Earth has air? Surprisingly, yes. When light passes through a planet's atmosphere, certain parts of that light get absorbed. Different gases absorb different colors, leaving behind subtle patterns. These patterns are like hidden signatures, and if you know how to read them, you can tell what gases are present. even from very far away. Think of it like hearing music through a wall. You can't see the instruments. You can't see the people playing, but you can still recognize the sound. You can tell if it's a piano, a guitar, or a drum. In the same way, scientists today can look at distant planets and detect gases like oxygen, carbon dioxide, and methane. So now imagine, if we can already do this with our current technology, what could a much more advanced civilization detect? Could they see Earth's atmosphere in detail? Could they notice that it contains oxygen, something that, on our planet, is strongly linked to life? This is where a common misunderstanding appears. Many people think oxygen automatically means life, but that's not always true. There are ways for oxygen to exist without life, under certain conditions. But here's the interesting part. It's not just one gas that matters, it's the combination. Earth's atmosphere contains oxygen and methane. At the same time, these two gases don't usually stay together for long without something constantly producing them. It's a bit like seeing steam and ice existing side by side. It feels unusual. It suggests that something active is maintaining that balance. So if someone were studying Earth's light carefully, they might notice that balance, and that could raise a quiet but powerful question. Is something alive there? But that's only part of the picture, because Earth doesn't just sit still, it rotates. As it spins, different parts of the planet come into view. Oceans, continents, clouds, all shifting slowly over time. If you were watching from far away, you might notice this gentle rhythm, a pattern repeating every 24 hours. Day, night, day, like a slow heartbeat. And over longer periods, you might notice something else, changes in color. As seasons pass, parts of the planet become greener or browner. Ice grows and shrinks near the poles. Cloud patterns shift. All of this adds another layer of information. It's like watching a living system breathe and move. So then, how visible is Earth, really? In one sense, it's small, just a tiny point in a vast sea of darkness. But in another sense, it's surprisingly expressive. It sends out signals through light, through motion, through chemical patterns. Not loud signals, not obvious ones, but enough that, if someone knew what to look for, they might notice. And that brings up another quiet question. How far away could someone be and still detect all of this? The answer depends on technology. With our current tools, we can study planets dozens or even hundreds of light years away, but only in limited detail. It's like trying to understand a city by looking at it through a foggy window from miles away. You can see shapes, you can notice changes, but the finer details are still hidden. But what if that fog didn't exist for them? What if their instruments were sharper, more sensitive, able to pick up even the faintest signals? Then Earth might not be so hard to notice after all. In fact, it might stand out more than we expect. Not because it's large, not because it's bright, but because it's active, alive, and quietly revealing that fact through the light it reflects into space. So now the thought settles a little deeper. If someone out there has the ability to read these signs, then Earth might already be visible to them, not as a detailed world full of people and cities, but as something unmistakably different, something that doesn't behave like a lifeless planet. And as that idea lingers, another question begins to form. If our planet is already giving off these subtle clues, have we also been sending out something much louder without even realizing it? As quiet as Earth may seem from far away, not everything we send into space is subtle. Some of it is much louder. And it all began not that long ago, just over 100 years ago. Something changed on this planet. in a way that had never happened before. Humans learned how to send signals without wires, invisible waves carrying sound, moving through the air at the speed of light. Radio. At first it was simple, short messages, basic transmissions, the kind of signals that stayed close to home, fading out after traveling a relatively short distance. But over time, those signals grew stronger, clearer, more powerful. It's a bit like speaking in a quiet room and then slowly turning that whisper into a voice, then into a shout, then into a broadcast that fills an entire city, and eventually something unexpected happened. That voice didn't just stay on Earth. It began to leak out into space, not in a focused beam, not aimed at any particular star, just spreading outward in all directions, like ripples moving across the surface of water after a stone is dropped. Except these ripples never slow down. They never stop. They just keep going forever. So then the question becomes, what exactly did we send? If someone far away could listen in, what would they hear? At first, it would be very simple. Early radio signals were not very complex. They carried basic information, often distorted, sometimes faint. But as time passed, those signals became richer. Music, voices, entire conversations. Later, television signals joined them. Images encoded into waves, telling stories, showing faces, capturing moments in time. Imagine that. Pieces of human life, drifting silently through space. A laugh, a song, a voice speaking words that no one out there may understand, but still exist, carried endlessly across the darkness. It's almost like leaving a trail behind you without realizing it. So how far have these signals gone? Since radio began in the early 1900s, those waves have been traveling for over 100 years. That means they have reached a distance of about 100 light years from Earth. To picture that, imagine drawing a circle around our planet that stretches outward in every direction. A sphere so large that light itself has taken a full century to cross it. If you could somehow see it from the outside, it would look like an expanding bubble. At the center, Earth, and spreading outward, a thin shell of signals, growing larger every second. But here's something interesting. Those signals don't stay strong forever. As they travel, they spread out. They become weaker, like a voice fading as it echoes across a wide open valley. If you shout in a small room, it sounds loud and clear, but if you shout across a massive field, your voice quickly becomes faint, almost impossible to hear. Radio waves behave in a similar way. So then, would anyone actually be able to detect them? That depends. If someone were very far away, our signals might be too weak to notice. They would blend into the natural background noise of the universe. But if someone were closer, within that expanding bubble, and if they had sensitive enough instruments, then yes, it's possible they could detect something. Maybe not clearly, maybe not enough to understand right away, but enough to notice that something unusual is happening. And that leads to a quiet but fascinating thought. The signals we sent out decades ago are still traveling right now, right at this moment, somewhere far away. There could be a distant point in space where the very first human radio broadcast is just arriving. A signal sent long before anyone alive today was born, finally reaching a place it has never touched before. And that signal would carry a snapshot of Earth from that time. Not modern Earth, not today's world, but a version of our planet from the past. It's almost like sending a message in a bottle, except the ocean is endless and the bottle never stops moving. So then, if someone were listening, they wouldn't hear us as we are now. They would hear us as we were. Which brings up a gentle question. What would those early signals say about us? They would reveal a world just beginning to explore technology. A world full of curiosity, discovery, and rapid change. They might hear simple broadcasts, old music, voices speaking in languages they don't understand. Would they recognize it as intelligent communication, or would it just sound like noise? After all, if you heard a completely unfamiliar signal with patterns you've never encountered before, would you immediately know it was a message, or would it take time to realize that there is meaning hidden within it? And then another thought appears: even if they could detect our signals, would they even be looking for them? Space is full of natural radio waves, stars, galaxies, and other cosmic events all produce their own signals. The universe is not silent, so our broadcasts would be just one small addition to that vast background, like a single voice in a crowded room. Unless you were paying very close attention, you might miss it entirely. But if you were searching, if you were scanning carefully, looking for patterns, for something that doesn't quite match the natural rhythm of the universe, then our signals might stand out, not because they are strong, but because they are structured, ordered, different. And that difference might be enough to raise a question, a simple one at first. What is that? And as that question forms, it might slowly grow into something deeper. Could it be someone? And back here on Earth, we continue to send more signals every day. Radio, television, radar, communication systems that quietly spill energy into space. Without any intention of being noticed, we are not trying to announce ourselves. We are simply living, and yet, in doing so, we may already be revealing our presence. Not loudly, not clearly, but enough that, somewhere within that expanding bubble, our existence is no longer completely hidden. And as that idea drifts gently through your mind, another question begins to take shape. If those signals keep traveling outward, just how large has that bubble become by now? If every signal we have ever sent continues to travel outward, never slowing down, never turning back, then something quiet but extraordinary is happening around us. We are leaving behind a growing shape, not something you can see with your eyes, not something you can touch, but something very real, a kind of invisible bubble, expanding in all directions from Earth, and it's getting larger every second. So how big is it now? To understand that, it helps to think in terms of light. Light travels incredibly fast. In just 1 second, it can circle the Earth more than 7 times. If you could somehow run alongside it, the entire planet would blur beneath you in an instant. But even at that speed, space is so vast that distance still takes time. When we say something is 1 light year away, we mean it takes light an entire year to get there. Now imagine that first radio signals began leaving Earth a little over 100 years ago. That means those signals have now traveled more than 100 light years in every direction. So the bubble around us has a radius of over 100 light years. To picture that, imagine standing in the center of a perfectly round sphere. From where you stand, every direction stretches outward the same distance. Now try to imagine that distance being so large that even light itself takes a century to reach the edge. It's difficult to fully grasp, but here's a simple way to feel it. If you could get into a car and drive non-stop at highway speed, it would take you over 150 million years to cover just 1 light year. Now multiply that by 100. That's the size of the bubble we've created, and it keeps growing. Every second, it expands a little more, like a breath that never ends. But what's inside this bubble? It's not empty. It's filled with every signal we've ever sent out into space. Old radio broadcasts, early television transmissions, military radar pulses, all layered together, spreading outward in a thin, ever-expanding shell. It's almost like a memory of humanity, moving away from us. But here's something important to understand. That bubble is not solid. It's not like a wall or a barrier. It's more like a fading echo. The farther it travels, the weaker it becomes. Imagine dropping a pebble into a still lake. At first, the ripples are strong and clear, but as they move outward, they spread thinner and thinner, until eventually they become almost impossible to see. Our signals behave in a similar way. So even though the bubble is large, the outer edges are very faint, which raises a quiet question. If someone is inside that bubble, could they actually detect us? The answer depends on two things: distance and sensitivity. If they are close enough, and if their technology is advanced enough, they might be able to pick up those signals. Not perfectly, not like tuning into a clear radio station, but enough to notice patterns, enough to realize that something unusual is happening. Now imagine a star system located, say, 50 light years away from Earth. That means our signals reach them about 50 years after we first sent them, and today they would have been receiving our broadcasts for decades. But here's something interesting. They wouldn't be hearing what we are sending right now. They would be hearing what we sent 50 years ago. It's like watching a delayed broadcast. Everything they detect from us is shifted into the past. So if they were observing Earth today, they might still be receiving signals from a time when technology looked very different. Old music, early television, voices from another era. And that leads to a fascinating realization. Different parts of space are receiving different versions of Earth. Closer regions are getting more recent signals. Farther regions are just beginning to receive our earliest ones. It's as if multiple snapshots of humanity are spreading outward at the same time, each one frozen in its own moment, each one telling a slightly different story. So then, what would this look like from the outside? Imagine you are far away, looking toward our solar system. You wouldn't see the signals themselves, but if you had the right instruments, you might detect a faint, expanding shell of energy. At the center, a quiet star, the sun, and around it, a growing sphere of artificial signals. Not natural, not random, but structured, organized, different from the background noise of space. And that difference might stand out. But here's where another thought comes in. What if someone is just outside that bubble, right at the edge? They wouldn't have detected us yet. From their point of view, Earth would still appear silent, empty, unnoticed. But at any moment, that first faint signal could arrive, a whisper from across the void. And in that instant, everything would change. Because now, they would know that something exists here, something active, something sending signals. And that realization might begin very simply. A strange pattern, a repeating signal, something that doesn't behave like natural radiation. And slowly, over time, that curiosity could grow. So then, how many stars are inside this bubble right now? More than you might expect. Within 100 light years of Earth, there are thousands of stars, many of them with planets. Some of those planets could be rocky, like Earth. Some might even have conditions suitable for life, so our signals have already passed by countless worlds, quietly, without announcement, without intention, just passing through. And as they continue to travel, they will reach even more. The bubble will keep expanding. 200 light years. 500, 1,000, always growing, always carrying fragments of who we are. And yet, despite all of this, we haven't received anything back. No clear reply, no confirmed signal, just silence. Which leads to another gentle question. Is no one there to hear us? Or is it simply that the distances are so vast that any response would take just as long to return? Because if someone 100 light years away heard our first signal and decided to reply immediately, their response would still be 100 years away from reaching us. a full century of waiting. So perhaps the silence isn't empty. Perhaps it's just delayed. And as that thought settles in, another idea slowly forms. If our signals have already spread this far, then what else might we be revealing about ourselves, beyond just radio waves? If our signals are like faint whispers moving through space, then our atmosphere is something different, but doesn't travel outward like radio waves. It stays wrapped around the planet, like a thin, delicate layer. But even though it stays in place, it still reveals something. The question is, could someone far away notice it? At first, that might sound unlikely. After all, how could you possibly detect something as thin as air from across such huge distances? But the answer lies in something surprisingly simple. Light. When light from a star passes through a planet's atmosphere, it doesn't come out unchanged. Some parts of that light get absorbed, some get scattered, and some pass through, carrying subtle clues about what they encountered. It's a bit like sunlight shining through a colored glass window. If the glass is blue, the light that comes through looks blue. If the glass is red, the light changes again. Now imagine that instead of colored glass, you have gases: oxygen, methane, carbon dioxide. Each one interacts with light in its own unique way. Each one leaves behind a kind of invisible signature. So if someone had the right tools, they wouldn't need to see the atmosphere directly. They could read those signatures, and from that, they could begin to understand what surrounds our planet. This might sound like advanced science, but we're already doing this ourselves. Right now, scientists study distant planets. By analyzing the light from their stars as it passes through their atmospheres, even though those planets are so far away that they appear as tiny points of light, we can still detect what gases are present. So then, what would Earth look like to someone doing the same thing? The first thing they might notice is oxygen. Earth's atmosphere contains a large amount of it, and that's unusual because oxygen doesn't just stay around forever on its own. It reacts easily with other elements. Over time, it should disappear, unless something keeps producing it. So if someone detected a strong oxygen signal from Earth, they might pause and wonder, what is creating that? And then they might notice something else. Methane, another gas, also present in our atmosphere. And here's where it gets interesting. Oxygen and methane don't usually coexist for long periods. They tend to react with each other and break down. So seeing both at the same time suggests that something is constantly replenishing them. It's like seeing a candle burning while someone keeps adding more wax. The flame continues, not because it's permanent, but because something is maintaining it. So then the question becomes, what could be maintaining those gases on Earth? This is where many people jump to a conclusion. They think, if there's oxygen, that must mean intelligent life. But that's not quite correct. Oxygen alone doesn't prove intelligence. It strongly suggests life, but not necessarily advanced life. Even simple organisms, like plants and tiny microbes, can produce oxygen. So if someone far away detected Earth's atmosphere, they might not immediately think of cities or technology. Instead, they might think, this planet is alive. And that alone is a powerful realization, because as far as we know, lifeless planets behave very differently. Their atmospheres are more stable, less active, more predictable. Earth, on the other hand, is constantly changing. Its atmosphere shifts, breathes, reacts. It's like a system in motion. So if someone were studying it carefully, they might notice those changes over time. They might see patterns, fluctuations, seasonal variations, and that could raise another quiet question. Is this just chemistry, or something more? Now imagine looking at Earth from a great distance. The way we look at distant planets, you wouldn't see forests or oceans directly, but you might detect hints of them. For example, plants on Earth reflect a certain kind of light, not something obvious to our eyes, but something that can be measured. It's almost like a faint signal hidden within the light itself, and this signal changes with the seasons. When plants grow, it becomes stronger. When they fade, it weakens. So from far away, Earth might appear to pulse gently with life, not in a dramatic way, not like something glowing brightly, but in a subtle, rhythmic pattern, like a slow, steady breath. And that leads to another thought. If someone could see all of this, would they recognize it immediately? Or would it take time to understand? After all, even here on Earth, it took us years to learn how to read these signals from other planets. At first, they were just data, numbers, patterns. Only later did they begin to make sense. So perhaps an alien civilization, even an advanced one, would go through a similar process. First noticing something unusual, then studying it, then slowly realizing what it might mean. And as that understanding grows, another question would naturally follow. If this planet is alive, is it inhabited? Because life can exist without intelligence, but intelligence leaves different kinds of traces, more structured, more deliberate. So maybe, at first, Earth would simply stand out as a living world. Rare, interesting, worth observing, and only later, after more careful study, would the possibility of intelligent life begin to appear. But here's something to consider. All of this depends on the ability to detect extremely faint signals, tiny changes in light, subtle chemical signatures. So the real question is not just whether Earth is visible, but how advanced the observer would need to be to notice it. Because with limited tools, Earth might still look like just another planet, but with more sensitive instruments, it could become something entirely different. Something unique, something that quietly stands out among countless others. And as that thought settles, another gentle question begins to form. If someone could already see that our planet is alive, what might they discover if their technology went even further, far beyond what we can imagine today? If it's already possible, with our current technology, to detect the faint signs of a planet's atmosphere from across vast distances, then it's natural to wonder how much further that ability could go. Because what we can do today is only a beginning. Our telescopes, as powerful as they are, still have limits. They collect light, they analyze it, and they help us piece together a picture, but it's a picture with missing details. It's a bit like trying to understand a city by looking at it through a window covered in thin fog. You can see shapes, you can notice movement, but the finer details remain just out of reach. So then, what if that fog didn't exist? What if someone had a way to see with complete clarity? The idea might sound far away, but if you think about how quickly human technology has advanced, it starts to feel less impossible. Just over 100 years ago, we were sending our first radio signals. Today, we can detect planets orbiting stars that are dozens, even hundreds of light years away. We can measure tiny dips in starlight as a planet passes in front of it, like noticing a small insect crossing a bright lamp from across a large room. That level of sensitivity is already remarkable. But what if it could go further? Imagine a telescope so powerful that instead of seeing a distant planet as a single point of light, it could begin to resolve features, not clear images like photographs, but hints, patterns, variations across the surface. It's similar to looking at Earth from very far away. At first, it's just a dot, but as you get closer, you begin to notice colors, then shapes, then movement. So the question becomes, could a more advanced civilization build instruments that go beyond what we can currently imagine? If they are even a few hundred or a few thousand years ahead of us in technology, the answer could be yes. And that leads to a fascinating thought. If their tools are more sensitive, more precise, more refined, then Earth might not just appear as a living planet. It might reveal even more. For example, they might be able to detect changes in light caused by artificial structures, cities, not in the sense of seeing buildings or streets, but in the way those structures interact with light. Materials like metal, glass, and concrete reflect light differently than natural surfaces like forests or oceans. So if a planet has large areas covered in artificial materials, that could create subtle patterns in the reflected light. Patterns that don't quite match anything found in nature. It's like looking at a landscape and noticing shapes that are too regular, too structured to be random. Straight lines, sharp edges, repeating forms. And even if those patterns are extremely faint, a powerful enough instrument might still detect them. But that raises another question. Would they be able to see our lights? At night, Earth glows. Cities light up the darkness, forming clusters of brightness across the surface. From space, these lights are clearly visible to satellites orbiting the planet. But from far away, much farther away, it becomes more difficult. The glow is faint, very faint, but not completely invisible. With enough sensitivity, it's possible that artificial lighting could be detected as a slight increase in brightness on the night side of the planet. Not as clear points of light, but as a gentle, uneven glow. Like seeing a distant shoreline at night, where you can't make out individual lights, but you can tell something is there. So then, if someone had the ability to measure that glow, what would they think? Would they recognize it as artificial, or would it simply appear as an unusual pattern, something that doesn't quite fit with natural processes? And then there's something even more subtle. Heat. Every object gives off heat, even if we can't see it. And different surfaces release heat in different ways. Cities, for example, tend to retain heat longer than natural landscapes. Concrete and asphalt absorb warmth during the day and release it slowly at night. This creates what we call heat islands. So if someone were observing Earth in infrared, a type of light that reveals heat, they might notice these patterns, areas that stay warmer than they should. Regions where the temperature doesn't behave naturally. Again, not obvious, but detectable. And all of this leads to a quiet realization. The more advanced the observer, the less hidden we become, because even if we don't send signals directly, even if we don't try to announce ourselves, our planet still leaves traces in light, in heat, in structure. So then, how far could this go? Could they see movement? Not individual people, of course. That level of detail would require being much closer, but they might detect changes over time, traffic patterns, seasonal activity, large-scale events that alter the surface of the planet. It's similar to watching a distant ant colony. From far away, you don't see each ant clearly, but you can still notice the flow, the movement, the organized behavior, and that behavior tells you something important, that there is structure, purpose, coordination, and that begins to hint at intelligence. But here's an interesting thought. Even with incredibly advanced technology, there are still limits. Light takes time to travel, so no matter how powerful their telescopes are, they can only see Earth as it was in the past. If they are 50 light years away, they see Earth as it was 50 years ago. If they are 100 light years away, they see signals from a century ago. It's like watching an old recording. No matter how clear the image is, so even if they can observe incredible detail, they are always looking backward in time. And that creates a strange kind of distance. Not just physical, but temporal. They might be watching a version of Earth that no longer exists, a world that has already changed, and yet, from their perspective, it is happening right now. So then the question becomes, if someone out there has the ability to see all of this to detect our atmosphere, our signals, even subtle traces of our activity, what would they do with that information? Would they simply observe? Would they study? Or would they try to look closer in ways we haven't even considered? And as that thought begins to settle, another idea slowly emerges. If they are observing us from afar, they might be seeing Earth the same way we look at distant planets, as just another world among many. If someone far away is observing Earth, there is a simple but powerful way to imagine what they might see. They would see our planet the same way we see distant worlds, not as a place filled with people, stories, and daily life, but as a small, distant planet orbiting the star. An exoplanet, that word, might sound complex at first, but it simply means a planet that exists outside our solar system, a world circling another star far beyond our reach. And over the past few decades, we've discovered thousands of them, each one just a tiny point of light, so small and far away that we can't see them directly in detail. Instead, we study them through indirect signs. We watch how their star's light dims slightly when the planet passes in front of it, like a tiny speck crossing a bright lamp. We analyze the light that filters through their atmosphere. We look for patterns, clues, subtle hints that tell us what these distant worlds might be like. So now imagine turning that perspective around. Imagine Earth becoming one of those distant points, a small, faint signal in the sky of another civilization. If they were studying us, what would they notice first? Most likely, they would notice our star. The sun would appear as just another star among billions, nothing special at first glance. But then, with careful observation, they might detect a tiny repeating change in its brightness, a slight dimming that happens at regular intervals. This would tell them something important, that a planet is passing in front of the star over and over again, like a clock. And by measuring that pattern, they could begin to understand our orbit. They could estimate how far Earth is from the Sun, how long it takes to complete one full journey, about 365 days. To picture this, imagine watching a distant lighthouse. Every so often, something small passes in front of the light, causing a brief shadow. If that shadow repeats at regular intervals, you begin to realize that something is orbiting the light. That's exactly how we detect many exoplanets today. So if they can detect Earth in this way, the next question naturally follows. Could they learn anything more? The answer is yes, because each time Earth passes in front of the Sun, a small portion of sunlight passes through our atmosphere before reaching them. And as we've already explored, that light carries information. So over time, they could begin to build a picture, not a visual image, but a kind of data portrait. They might learn that Earth has an atmosphere, that it contains oxygen, that there are clouds, water vapor, perhaps even signs of changing weather. It's like listening to a distant song and slowly recognizing the instruments one by one. At first, it's just sound. Then you notice a rhythm, then a melody, and eventually it becomes something meaningful. But here's something interesting to consider. Even with all this information, Earth would still appear incredibly small. From far away, it might be no larger than a single pixel on a screen. A tiny dot of light, barely noticeable unless you know exactly where to look. To help picture that, imagine looking at a photograph of the night sky filled with thousands of stars. Now pick one star at random. That's how small and hidden Earth might appear from another system. So then, why would anyone pay attention to it? Why focus on such a tiny, distant world? The answer lies in patterns, because not all planets are the same. Some are too close to their stars, burning hot. Others are too far, frozen and dark. But Earth sits in a very special position, a distance where temperatures allow liquid water to exist. Not too hot, not too cold, just right. It's often called the habitable zone. You can think of it like standing near a fire. If you're too close, it becomes unbearable. If you're too far, you feel nothing. But there's a perfect spot where the warmth is comfortable. Earth sits in that spot around the sun. And that alone makes it interesting. So if someone was scanning the sky, looking for planets that might support life, Earth would likely stand out as a candidate, not because it's obvious, but because it fits the right conditions. And then, once they begin studying it more closely, they might notice those atmospheric signatures: oxygen, methane, water vapor, and slowly the picture becomes clearer. This is not just a planet. This is a planet with activity, with change, possibly with life, but still, from their perspective, it remains distant, abstract. They wouldn't see cities. They wouldn't see movement in the way we experience it. Instead, they would see trends over time, slow changes, shifts in light, patterns repeating again and again. It's almost like studying a heartbeat on a monitor. You don't see the person directly, but you can tell that something is alive. And that raises another quiet question. Would they feel curiosity? The same kind of curiosity we feel when we discover a new exoplanet that looks promising, when we find a world that might have water, or an atmosphere, or the right conditions for life. We become interested. We study it. We observe it again and again. So perhaps, from their point of view, Earth would be just that. A point of interest. A world worth watching, not because they know what's here, but because something about it feels different. Something that invites closer attention, and over time, as they gather more data, more observations, more subtle clues, that curiosity might grow from a simple question: what kind of planet is this? To something deeper: is there something living there? And eventually, is there someone there? But even then, the distance remains. They are still far away, still looking at a tiny dot of light, still piecing together a story from fragments. And that leads to another thought. If they are watching us this way, through light and patterns, then everything they know about Earth is carried by that light itself, which brings up a simple but fascinating question. What exactly is that light revealing as it travels through space? If someone were observing Earth from far away, everything they know about us would come from one thing: light. Not sound, not direct images, just light, traveling across the darkness of space. And that light carries more information than it might seem. At first it feels simple. Light reflects off the surface of a planet and moves outward, like a quiet glow spreading into the distance. But within that glow, there are details, hidden patterns, tiny changes that reveal what's happening on the surface, even from far away. So what exactly could they learn just by studying Earth's light? To understand this, imagine holding a small mirror in sunlight. As you tilt it, the reflection changes, the brightness shifts, the angle of the light moves. Now imagine that mirror is not smooth. Instead, it's made of oceans, forests, deserts, and clouds. Each part reflects light differently. Water reflects light in a smooth, almost shimmering way, like sunlight dancing on the surface of a lake. Land reflects light in a rougher, more scattered pattern. Clouds bounce light strongly, appearing bright and soft. So as Earth rotates, all of these surfaces move in and out of view, and that causes the light coming from our planet to change over time. Not dramatically, not in a way we would notice with our eyes, but enough that, with careful measurement, those changes become meaningful. It's a bit like watching a spinning disco ball in a dark room. As it turns, small flashes of light move across the walls. If you were paying close attention, you could tell that something is rotating, even if you couldn't see the ball itself. In the same way, an observer could detect that Earth is spinning. They would see repeating patterns in brightness, rising and falling in a steady rhythm, about once every 24 hours. And that rhythm tells a story. Day turning into night, night turning into day. A consistent cycle. But that's just the beginning. Because light doesn't only change with rotation, it also changes with what's on the surface. For example, oceans behave differently than land. Water tends to reflect light in a more focused way, creating a kind of bright glint when the angle is just right. It's similar to looking at the ocean at sunset, when the sunlight forms a long, bright streak across the water. From far away, this effect can still be detected, and it gives a clue that large bodies of liquid might be present. So then, could someone detect Earth's oceans just from light? Possibly, yes. By observing how the brightness shifts as the planet rotates, they might notice patterns that suggest large, smooth, reflective areas. Areas that behave differently from land, and that could hint at something remarkable. Liquid water. Now imagine what that means. Water is one of the key ingredients for life, as we understand it, so detecting it would immediately make Earth more interesting, more worth studying. But there's more. Clouds, they move constantly, forming and fading, drifting across the planet, and they reflect a lot of light. So from a distance, Earth's brightness would not be perfectly steady. It would flicker slightly, like a candle flame moving in a gentle breeze. These small variations could reveal that the planet has weather, an active atmosphere, something dynamic, not still. And that leads to another question. Could they tell that Earth has seasons? Over longer periods, the answer might be yes. As the planet orbits the sun, different parts receive more or less sunlight. Ice expands and contracts near the poles. Vegetation changes color and density. All of this affects how light is reflected. It's subtle, but over months and years, patterns begin to emerge. It's like watching a tree through the seasons. At first, it's just there, but over time, you notice the leaves growing, changing, falling, and you begin to understand the cycle. So from far away, Earth might appear to have a slow, repeating rhythm. Not just daily rotation, but yearly change, and that rhythm suggests something important, a stable, ongoing system. Now here's a gentle question. If someone could see all of this, would they realize that life is present, or would it still feel uncertain? Because while these signs point toward life, they don't prove it completely. They suggest possibility, not certainty. It's like seeing smoke in the distance. You might think there's a fire, but you can't be sure until you get closer. And that brings us to another layer of light, artificial light. At night, parts of Earth glow with human-made illumination. Cities shine, roads form faint lines, clusters of light appear where people live. From close orbit, these are clearly visible, but from far away, they become much fainter, not entirely invisible. With sensitive enough instruments, it's possible that this artificial glow could be detected as a slight increase in brightness on the dark side of the planet, not sharp or detailed, just a soft, uneven glow, like seeing a distant village from across a valley at night, where you can't see individual lights, but you know something is there. So then, if someone detected that glow, what would they think? Would they recognize it as artificial? Or would it simply appear as another unusual feature? Perhaps it would raise questions, patterns that don't match natural light sources, regions that stay illuminated even when they shouldn't, And slowly, those questions could build, because light doesn't just reveal what is present, it also reveals what doesn't belong. Things that break the expected patterns. And those differences are often the most noticeable. So if Earth's light carries all of this information, rotation, water, clouds, seasons, possible artificial illumination, then, in a way, our planet is constantly telling a story, not in words, not in images, but in patterns. And anyone patient enough, anyone with the right tools, could begin to read that story, piece by piece, moment by moment. But there's one more important detail. Every bit of light that leaves Earth takes time to travel. So what they see is never happening right now. It's always delayed, always from the past, which leads to a quiet and fascinating thought. If someone is watching Earth through light, they might not be seeing us as we are today, but as we were long ago. If everything we send into space, light, radio waves, every tiny signal, travels at the same ultimate speed, then there is something important to understand. Nothing arrives instantly. Everything takes time, and not just a little time, sometimes a very long time. This creates a quiet but powerful effect. Anyone watching Earth from far away is not seeing the present moment. They are seeing the past. At first, that might feel a bit strange. We're used to thinking of observation as something immediate. You look at something and you see it as it is right now. But in space, it doesn't work that way. Even here on Earth, light takes a small amount of time to reach your eyes. It's so fast that we never notice it. But when distances grow, that delay becomes real, noticeable, meaningful. So, how does this work when it comes to Earth? Imagine someone is observing our planet from a distance of 10 light years away. That means the light they see today left Earth 10 years ago. So if they are watching Earth right now, they are actually seeing Earth as it was 10 years in the past. Everything they observe is delayed, like watching a recording instead of a live broadcast. Now imagine someone even farther away, 50 light years. They would be seeing Earth as it was 50 years ago. A completely different time, different technology, different people, different events. And if we go even farther, 100 light years away, they would just now be receiving the very first radio signals we ever sent. They wouldn't know anything about the modern world yet. No smartphones, no internet, no recent history. From their point of view, all of that hasn't happened yet. It's still in the future. To help picture this, imagine watching an old home video. The people in the video are younger, the world looks different. But for the people inside that video, everything feels like the present. They don't know what comes next. In the same way, distant observers would see Earth frozen in different moments of its timeline. Each distance reveals a different version of us. Closer observers see more recent history. Farther observers see deeper into the past. So then, what does that mean for the idea of being watched? It means that even if someone is observing Earth right now, they are not seeing you as you are in this moment. They are seeing a version of Earth that already happened, which raises a gentle question. Could someone out there be watching a completely different version of our world? The answer is yes. Someone 200 light years away would be seeing Earth as it was 200 years ago, a time before radio, before electricity in most places, before modern cities as we know them today. From their perspective, Earth might still look quiet, natural, perhaps even primitive. They wouldn't know what we've become since then, and that leads to an interesting thought. Different parts of the universe hold different snapshots of Earth, all existing at the same time, all moving outward through space. It's like taking a series of photographs and sending each one in a different direction. Each photo captures a different moment, And as they travel, they spread those moments across the universe. So somewhere out there, Earth is still in its early stages. Somewhere else, it's more advanced. And somewhere closer, it might appear almost as it does today. All of these versions exist, not physically, but as information carried by light. Now here's where it becomes even more fascinating. What if someone decided to respond? Let's say a civilization 100 light years away detects our signals and sends a reply immediately. That reply would take another 100 years to reach us, so by the time we receive it, 200 years will have passed since our original signal left Earth. To picture that, imagine sending a message today and only receiving a reply in the year 2226. A full 2 centuries later. That's the kind of delay we're dealing with. So even if communication is possible, it's incredibly slow, almost like a conversation stretched across generations, and that might explain something important. Why we haven't heard anything back. It's not necessarily because no one is there. It might simply be because time, on this scale, moves differently. Messages take decades, centuries, even longer to travel back and forth. So silence doesn't always mean absence. Sometimes it just means waiting. Now here's another question. If someone is observing Earth, would they even realize that what they're seeing is delayed? For an advanced civilization, likely yes. They would understand how light travels. They would know that they are looking into the past. But even with that knowledge, there is still a kind of separation, because no matter how clearly they can see, they cannot see the present. They cannot know what is happening on Earth right now, and neither can we see them as they are now. If we observe a star system 50 light years away, we are seeing it as it was 50 years ago. Whatever is happening there today, we won't know for another 50 years. So both sides are always looking backward, always observing history, never the present. It's like two people trying to watch each other through delayed recordings, each one seeing the other, but always a step behind. And that creates a quiet kind of distance, not just in space, but in time. So when we ask, could aliens be watching us right now? The answer becomes a little more complex. Yes, they could be watching, but what they see is not right now in the way we experience it. They see echoes, reflections, moments that have already passed, and that leads to a final, gentle thought. For this moment, if someone far away is watching Earth through this delayed light, there is a chance that what they are seeing is not humanity at all, but something much older. If distance turns the present into the past, then the universe becomes something unexpected, a kind of living timeline. Everywhere you look, you are seeing a different moment. And somewhere out there, if the distance is great enough, Earth does not look like it does today. It looks ancient, much older, a version of our planet from a time long before cities, before technology, before humans. So then, a quiet question appears. Could someone be watching Earth right now and seeing dinosaurs? The answer, surprisingly, is yes. If an observer is far enough away, the light they receive from Earth could be from millions of years ago. To understand this, think about how long light takes to travel. We've already seen that light from 100 light years away. Shows us Earth as it was 100 years ago. So what if the distance is much greater? What if someone is 65 million light years away? That's roughly the time when the last dinosaurs lived on Earth. If they had a powerful enough way to observe our planet, the light reaching them today would be carrying images from that time. Not modern Earth, not human civilization, but a world filled with vast forests, giant creatures, and no sign of anything we would recognize today. To help picture that, imagine watching a nature documentary. You see animals moving, landscapes changing, life unfolding. But everything you're watching was recorded long ago. The events have already happened. You're just seeing them now. In the same way, distant observers would be watching a recording of Earth's past, carried to them by light. So somewhere out there, at this very moment, Earth might still be a place where enormous creatures roam, where no cities exist, where the surface of the planet looks completely different. And from their perspective, that is the present. They would have no way of knowing what comes next, no knowledge of extinction events, of evolution, of the rise of humans. All of that lies in the future, waiting to arrive in the light that has not yet reached them. And that leads to an interesting thought. If they were studying Earth, what would they conclude? They might see a planet rich with life. They might notice movement, growth, patterns in ecosystems. They might even recognize that life is complex and widespread. But would they expect intelligence? Would they imagine that millions of years later, a species would emerge capable of building technology, sending signals, and asking questions about the universe? Or would Earth simply appear as a wild, natural world, one of many? It's possible that, from that distance, there would be no sign of anything unusual, no radio signals, no artificial lights, no structures, just life in its raw, natural form. And that brings up a gentle question. How many different versions of Earth exist out there right now in the form of light? Because every moment in our planet's history has been recorded in the light that left it. Each second, each day, each year, all of it is moving outward. So somewhere, Earth is still forming, a young planet, covered in molten rock. Somewhere else, it's cooling, oceans beginning to appear. In another region, life is just starting. Simple, microscopic, and farther out, the age of dinosaurs is still unfolding. All of these moments exist at the same time, just at different distances. It's like a series of ripples, each one carrying a different snapshot. And as those ripples expand, they spread the story of Earth across the universe. So then, if someone were watching us from far enough away, they might not even know we exist. Not yet, because the light that reveals us hasn't reached them. From their point of view, humanity hasn't happened, and that's a strange and quiet idea, that our existence is not yet visible to certain parts of the universe, not because we're hidden, but because the information simply hasn't arrived. Now here's something else to consider. Even if someone is at the right distance to see dinosaurs, would they actually be able to see them clearly? The answer depends on technology, because at such vast distances, Earth would appear incredibly small, even smaller than a single pixel. So while the light carries the information, extracting detailed images would be extremely difficult. It would require instruments far beyond what we currently have. Still, they might detect changes, movement, patterns that suggest a living world, but the finer details, individual creatures, specific forms, might remain hidden. So perhaps they wouldn't literally see dinosaurs walking, but they might detect a planet full of life during that era, a world that behaves differently from a lifeless one, and that alone would be enough to spark curiosity, to begin asking questions, to observe more closely, and over time, as they continue to study, they might notice changes, because Earth doesn't stay the same, it evolves. So if they observe long enough, they might see shifts in the atmosphere, changes in the surface, gradual transformations that hint at something deeper happening. And eventually, the signals of human activity would begin to arrive. Faint at first, subtle, easy to miss, but present. So from their perspective, Earth's story would unfold slowly, like watching a very long film, one frame at a time, millions of years passing in what feels like a continuous observation. And that leads to a quiet realization. No matter where you are in the universe, you are always looking into the past. You are always seeing what has already happened. So when we wonder if someone is watching us, the answer may depend entirely on where they are. Some might be seeing our present, some might be seeing our past, and some might not see us at all yet. But as time continues and light keeps traveling, every moment of our existence will eventually reach them. And when it does, a new question will form. If someone is close enough, not millions of light years away, but much nearer, what version of Earth would they be seeing right now? If distance decides what version of Earth is visible, then something important begins to shift as we move closer. Not millions of light years away, not deep in the ancient past, but within a much smaller neighborhood, our local region of space. Because while some observers might still be seeing dinosaurs, others, much closer, could be seeing something very different, something far more familiar. They could be seeing us. Right now, there are stars relatively close to Earth. In cosmic terms, close still means very far, but compared to the rest of the universe, these distances are small. Some stars are only a few light years away. Others, maybe 10, 20, or 50 light years. And as we've already explored, that distance matters. If a civilization exists around a star 10 light years away, then the light they see from Earth today left our planet just 10 years ago. That's not ancient history. That's recent. If they are 20 light years away, they see Earth as it was 20 years ago. Still modern. Still clearly human. So now the question becomes, if someone exists nearby, what would they actually be seeing? They wouldn't see individual people walking around. They wouldn't see conversations or small details, but they might see something else, patterns, large-scale activity, evidence that something on this planet is organized and active. For example, they might detect our radio signals. Unlike distant observers, who receive only the earliest and weakest signals, closer civilizations would be receiving stronger, more recent ones, clearer, richer, more complex. They might detect structured broadcasts, repeating patterns, signals that don't behave like natural cosmic noise, and over time, they might begin to recognize that these signals are not random. They carry information. They are intentional. It's similar to hearing a faint sound in the distance. At first, it's just noise. But as it becomes clearer, you begin to notice rhythm, structure, meaning. So if they are close enough, they might realize that Earth is not just a living planet, but a planet with intelligence. Now here's a gentle question. Would they understand our signals? Probably not right away. Our languages, our symbols, our sounds, they are shaped by human experience. To someone completely different, they might seem strange, unfamiliar. But even without understanding the content, they could still recognize the patterns. Repetition, order, complexity. And those are strong hints of intelligence, because natural signals, like those from stars or galaxies, tend to be more random or follow simple physical rules. But artificial signals, they often carry layers of structure. So detecting that structure could be enough to raise a powerful question. Is someone there? Now imagine they continue observing. Over years, decades, maybe longer, they collect more data, more signals, and slowly, a picture begins to form, not a visual image, but an understanding. They might notice that the signals change over time. Technology evolves, broadcasts become more advanced, new types of communication appear. It's like listening to a long conversation and noticing how it grows more complex. And that growth suggests something important. Progress, development, a civilization that is changing, learning, expanding, and that could make Earth even more interesting to observe. But there's more. Closer observers might also detect other signs, subtle ones. For example, the increase in artificial light on the night side of the planet, the patterns of heat from cities, changes in the atmosphere caused by industrial activity. All of these are small signals, but together they form a pattern that doesn't match a natural world. So if someone nearby has the ability to detect these things, Earth might stand out very clearly, not just as a planet with life, but as a planet with technology. And that changes everything, because life can be common, simple life at least. But technological life, that might be much rarer, so detecting it could be significant, worth paying attention to, worth studying. And that leads to another question. If they can see us, how long have they been watching? Because even at 10 or 20 light years away, they would have only recently started receiving our signals. Just a few decades ago, Earth might have appeared quiet to them, natural, unremarkable. Then suddenly, something changes. New signals begin to arrive, stronger, more complex. And over time, they grow. So from their perspective, Earth might look like a planet that has just recently become active, like a quiet place that suddenly started speaking, and that could be surprising, even intriguing. But here's something to think about. Even if they are close enough to detect us, that doesn't mean they are close enough to interact easily, because the same distance that allows them to see us also creates a barrier. If they are 20 light years away, any message they send would take 20 years to reach us, and another 20 years for our reply to reach them. A full 40 years for a single exchange. It's like trying to have a conversation where each sentence takes decades to deliver. So even nearby civilizations are still separated by time, still distant, still unable to communicate quickly. And that might explain something important. Why observation could be the easiest option. Watching is simple. It requires no response, no risk, just patience. So perhaps, if someone nearby is aware of us, they might choose to observe quietly, to gather information, to learn, without making their presence known. And that leads to a final, gentle thought. If someone close enough can already see our signals, our patterns, our activity, then it's possible that somewhere not too far away, Earth is no longer just a quiet planet. It is something noticeable, something understood, something being watched, not in the distant past, but in a version of the present that is still unfolding. So far, the idea of being watched has felt distant, observers far away, studying light, signals, patterns, all from across vast stretches of space. But what if observation didn't have to happen from so far away? What if, instead of watching from a distance, something could come closer? Not a large ship, not something obvious, but something small, quiet, almost invisible. This leads to a different kind of question. Could there be probes already here, or somewhere nearby, simply observing? At first, the idea might sound like something from a story, but if we think about it carefully, it begins to feel more practical than it seems. Because sending a full civilization across space is incredibly difficult. The distances are enormous. The energy required would be immense. It's like trying to cross an ocean the size of the entire Earth. But with no clear destination, no map, and no guarantee of success. So instead of sending people or living beings, what if a civilization chose to send machines? Small, durable, long-lasting machines, designed not to interact, but simply to observe. We already do something similar. Humans have sent probes to Mars, to distant planets, even beyond the edge of our solar system. Some of them continue to travel, carrying small pieces of information about who we are. And compared to what might be possible in the future, our probes are still very simple. So imagine a civilization much more advanced than ours. Their probes could be far more capable, more efficient, able to travel longer distances, able to operate for much longer periods of time, maybe even thousands or millions of years. So then the question becomes, if such probes exist, where would they be? They wouldn't need to be close to the surface of Earth. In fact, that might be the least practical place. Instead, they might stay at a distance. Quiet orbits, stable positions, places where they can observe without being noticed. For example, they could be somewhere in deep space within our solar system, far beyond the planets, or even hidden among natural objects, like asteroids. It's a bit like placing a camera far away from a city, high on a distant hill. From there, you can observe patterns, lights, movement, without being seen. And that leads to another thought. Would we even recognize such a probe? If it were there, probably not, because we tend to look for things we understand. Satellites, spacecraft, objects that match our expectations. But something truly unfamiliar, something designed by a different intelligence, might not look like anything we recognize. It might not send obvious signals. It might not move in ways we expect. It could be silent, inactive most of the time, simply watching. So even if it were present, it might blend into the background of space. Just another object among countless others. Now here's a gentle question. Why would a civilization send probes instead of coming themselves? The answer could be simplicity, efficiency, safety. Sending a probe is far less risky than sending living beings. It doesn't require life support. It doesn't need to return. It can travel slowly, patiently, without urgency, and most importantly, it can observe without disturbing. Because if the goal is to learn, to study, to understand, then staying hidden might be the best approach. It avoids interference. It allows natural behavior to continue. It keeps the observation pure. It's similar to how scientists study animals in the wild. If you walk directly into their environment, they change their behavior. They become aware of you. But if you observe from a distance or use hidden cameras, you see them as they truly are. So perhaps an advanced civilization would take a similar approach, not interfering, not revealing themselves, just watching, quietly, over long periods of time. And that raises another question. How long could such a probe remain active? If built with advanced technology, possibly a very long time. Long enough to observe entire generations, to watch changes unfold slowly, to gather information over centuries. It's difficult to imagine, but think of it this way. Some of our own spacecraft have been operating for decades already, and that's with relatively early technology. Now imagine extending that lifespan, not by years, but by thousands of years. A probe that continues to function long after it was sent, still observing, still recording, still present. And if that's possible, then another thought begins to form. If probes can last that long, then they might not need to be sent recently. They could have been sent a very long time ago, before human civilization reached its current state, before we had the ability to detect anything unusual. And they could still be here. Now, this doesn't mean that such probes definitely exist. There is no confirmed evidence, but the idea itself is not impossible. It follows a kind of logic. If a civilization wants to explore the galaxy, if it wants to observe other worlds, then sending probes could be one of the most effective ways to do it. And that leads to a final, quiet question. If something like that were already here, watching silently, would we even know? Or would it remain completely unnoticed? Just another small presence in the vastness of space, observing without ever revealing itself. If sending a single probe across space is possible, Then another idea begins to take shape. What if one probe isn't enough? What if, instead of sending just one, a civilization sends something that can make more of itself? At first, that might sound unusual. But if you think about it, it follows a simple pattern we already see in nature. Living things reproduce. A single seed becomes a tree. That tree produces more seeds. And over time, a whole forest can grow from something very small. So then, what if machines could do something similar? Not living machines, but machines designed to build copies of themselves, using materials they find in space. This idea is often described as a kind of self-replicating probe. A machine that travels to a new location, gathers resources, builds a copy of itself, and then sends that copy further outward, and then the process repeats, again and again, spreading across space over time. To picture this, imagine placing a single drop of ink into water. At first, it's just one small point, but slowly it spreads, expanding outward in all directions. Now imagine that instead of spreading smoothly, each drop creates more drops, and each of those creates even more. The growth wouldn't just be steady, it would increase, faster and faster. So then the question becomes, how far could something like that spread? If a probe could create copies of itself, and each copy continues the process, then over long periods of time, it could reach an enormous number of star systems. Even if each step takes many years, or even centuries, the process continues. Patient, unstoppable, like a slow wave moving through the galaxy. And that leads to a fascinating thought. If such machines exist, they wouldn't need to travel quickly. They wouldn't need to rush. They could move slowly, carefully, using time as their advantage. Even if it takes thousands of years to reach the next star, that doesn't matter, because once the process begins, it continues. So then, could something like this have already happened? It's difficult to say. There is no clear evidence that such machines exist, but the idea itself is not impossible. It's based on simple principles: replication, expansion, efficiency. And if a civilization is advanced enough, it might see this as a practical way to explore the galaxy. Instead of sending large ships, instead of risking lives, they send small, self-sustaining systems that can spread on their own. Now here's a gentle question. If such probes were moving through the galaxy, what would they do when they reach a place like our solar system? They might slow down, observe, collect information, maybe use local materials to create more copies. Asteroids, for example, contain metals and other resources. A probe could use those materials to build new units, and all of this could happen quietly, without drawing attention, because the goal wouldn't be to interact. It would be to observe, to gather data, to understand. It's similar to how we might send multiple sensors into a large environment, each one collecting information, building a larger picture. So if these machines exist, they might form a kind of network, spread across many star systems, each one contributing small pieces of information, and together they create a vast map of the galaxy. Now imagine that for a moment, a network of silent observers, not communicating in ways we can easily detect, not announcing their presence, just existing, recording. And that leads to another thought. Would we even notice them? If they are small, quiet, and designed to avoid detection, they might blend into the background, just like a tiny insect in a forest. Unless you know exactly where to look, you might never see it. And space is far larger than any forest, so even if such probes are present, they could remain unnoticed. Now here's something interesting to consider. Why would a civilization choose this method? Why not explore directly, The answer might be scale. The galaxy is enormous. Traveling across it physically is difficult, but spreading through it gradually, using self-replication, might be more efficient. It's like sending one explorer into a vast land, versus planting something that grows and spreads over time. One is limited, the other expands. So if the goal is to observe many worlds, to learn about different environments, to gather knowledge, then self-replicating probes could be an effective approach. But there is also a question of control, because once something can replicate itself, it continues, it spreads, and that raises an important thought. Would such machines be carefully designed to follow strict rules, to avoid interfering with the worlds they observe, to remain hidden? It seems likely, because uncontrolled replication could create problems. So any advanced civilization would probably design these probes with clear limits, clear purposes, observation, not interference, learning, not changing. And that idea connects to something deeper, the possibility that observation might be happening all around us, but in ways we don't recognize. Not through large, visible objects, not through obvious signs, but through small, quiet systems, operating patiently over long periods of time. And as that thought settles, another question begins to form. If such observers could spread across the galaxy, then could some of them already be here, hidden somewhere within our own solar system? If observation can happen from far away, and if probes or machines could travel quietly through space, then a simple but intriguing question begins to form. What if something is already here, not on Earth, not walking among us, but somewhere within our own solar system, watching from a distance? At first, that idea might feel unlikely. After all, we've explored space. We've sent satellites, telescopes and probes to many places. We've mapped planets, studied moons, and tracked countless objects. So, wouldn't we have noticed something unusual by now? But the solar system is much larger than it might seem. Even though we often see diagrams showing the planets close together, those images are not to scale. The real distances are enormous. To picture this, imagine placing the sun at one end of a large field. If Earth were just a small bead a few steps away, then the outer planets would be hundreds of steps farther out, and beyond that, even more space, empty, quiet. So even within our own solar system, there are huge regions that we haven't explored in detail, places where something small could exist without being easily detected. Now here's a gentle question. Where would be the best place for something to observe us without being noticed? It wouldn't need to be close to Earth. In fact, being too close might increase the chance of detection. Instead, it could stay farther away, hidden among natural objects. For example, the asteroid belt, this region between Mars and Jupiter, contains millions of rocks, ranging from small pebbles to large bodies. It's like a wide field filled with scattered stones. Now imagine placing a small object among them, something that doesn't reflect light in an unusual way, something that doesn't move differently from the rest. It could easily blend in. Another possibility could be farther out, beyond the outer planets, where sunlight is weaker and objects are harder to detect. In these distant regions, even large objects can be difficult to observe clearly. So a small, quiet probe could remain hidden there, watching, collecting information without drawing attention. But then another question appears. Would such an observer need to be physically present to watch us? Or could it rely on other methods? If it has advanced technology, it might not need to come close at all. It could observe from a stable position, using sensors far more sensitive than ours. It might detect signals, light, heat, patterns, all from a distance. Just as we observe distant planets, so even if something were within our solar system, it might still remain far away from Earth itself. Now, here's something to consider. We often assume that if something is here, it would behave in ways we can detect. It would send signals, move in noticeable patterns, or interact with its surroundings. But that assumption is based on our own technology, our own way of doing things. Something more advanced might not behave that way at all. It might be designed specifically to avoid detection, to remain still, to emit no signals, to blend in completely. It's like hiding in plain sight. If something doesn't stand out, it becomes part of the background, and the background is easy to overlook. Now imagine for a moment an object sitting quietly on the surface of an asteroid, not moving, not shining, not sending out any obvious signal, just existing. From a distance, it would look like part of the asteroid itself. Unless you examined it very closely, you might never notice it. And even if you did notice something unusual, you might not immediately understand what it is, because it wouldn't match anything familiar. And that leads to another thought. Even if something like this were present, we might not yet have the tools to recognize it. We are still learning, still improving our ability to observe space. Each new telescope, each new mission, reveals more than before. But there are still limits, still gaps in what we can see. So the idea of hidden observers doesn't rely on something obvious. It relies on subtlety, on the possibility that something could exist without drawing attention. Now here's a gentle question. Why would something choose to stay hidden? The answer might be the same as before. Observation. If the goal is to study a planet, to understand its development, its behavior, its life, then remaining unnoticed might be important. Because once a civilization knows it is being watched, it changes, behavior shifts, decisions are influenced, the natural course is altered. So by staying hidden, an observer can see things as they truly are, unchanged, unaware. It's similar to watching wildlife. If animals sense your presence, they react, but if you observe quietly, from a distance, you see their natural behavior. So perhaps, if something is observing Earth, it would choose to do so without revealing itself, not out of fear, but out of purpose, to keep the observation pure. And that leads to a final, quiet thought. If something were already here, somewhere in the vastness of our own solar system, watching silently, would there be any sign at all, or would it remain completely hidden, blending into the quiet background of space, observing without ever being noticed? If the possibility of observers, signals, or even quiet probes feels real, then another question gently rises. Why haven't we found anything? If someone is watching, if signals exist, if probes could be out there, why does everything still feel so silent? At first, it might seem like the answer is simple. Maybe there's nothing there. Maybe we are alone, but the more we think about it, the more we realize that silence doesn't always mean absence. Sometimes it simply means we haven't noticed, or we don't yet know how to notice. To understand this, imagine being in a large forest at night. You stand still, listening. At first, it feels quiet, empty. But as your ears adjust, you begin to hear more. Insects, wind moving through leaves, distant sounds you didn't notice before. The forest was never silent. You just weren't tuned in yet. Space might be similar, not empty, just difficult to read. Now think about how we search for signs of life. We use telescopes, we scan for radio signals, we look for patterns that don't match natural processes. But all of this depends on something important. We are looking for what we expect to find. Signals like ours, technology like ours, patterns that make sense to us. But what if something out there doesn't match those expectations? What if it communicates differently, uses signals we don't recognize, or doesn't send signals at all. It would be like trying to listen for a specific language in a crowded room. If someone is speaking a completely unfamiliar language, you might hear the sound, but not recognize it as meaningful. It blends into the background. And that leads to another question. Are we missing something simply because we don't understand it yet? It's possible, because our tools, as advanced as they are still limited. We can only detect certain ranges of light, certain types of signals, certain patterns. It's like having a flashlight in a dark room. You can only see what the light touches. Everything outside that beam remains hidden. Now imagine that something exists just outside that beam, not invisible, just outside our range. We wouldn't see it, not because it isn't there, but because we're not looking in the right way. And that brings up another thought. Even if something is detectable, it might be extremely faint. Signals weaken over distance. Light fades, patterns become harder to distinguish. So an alien signal might be there, but buried under cosmic noise, like trying to hear a whisper in a room full of static. Unless you know exactly what to listen for, it's easy to miss. Now here's a common belief that often comes up. Many people think that if advanced civilizations exist, they would send strong, clear signals. Something obvious, something impossible to miss, but that assumes they want to be found. What if they don't? What if they choose to remain quiet, or communicate in ways that are not easily detected, or limit their signals to specific directions, instead of broadcasting in all directions like we do? In that case, their presence could be very real, but very hard to notice. And then there's another possibility. They might be too advanced. This might sound strange at first, but think about how technology evolves. As systems become more efficient, they often become quieter, more compact, less noticeable. Early machines are large and noisy. Modern ones are smaller, faster, and quieter. So if a civilization is far ahead of us, their technology might not produce strong, obvious signals. It might be subtle, efficient, almost invisible. It's like comparing a bright, flickering torch to a small, steady LED light. Both produce light, but one is much easier to notice from a distance. So perhaps we are expecting to see torches when what exists are quiet, refined signals we don't yet recognize. Now here's another question. What if we have already detected something, but didn't realize it? Throughout history, there have been strange signals, unusual observations, things that didn't immediately make sense. Most of them are eventually explained. Natural phenomena, instrument errors, misinterpretations. But sometimes there are moments that remain unclear, not confirmed as anything extraordinary, but not fully understood either. And that leaves a small space of possibility, not proof, just uncertainty. And in that uncertainty, questions remain. Now consider something else. The universe is incredibly old, far older than human civilization. If other civilizations exist, some might be much older than us, thousands, millions, even billions of years ahead. And that creates a kind of gap, a difference in development that might be hard to bridge. It's like comparing a modern computer to a simple tool from ancient times. The difference is so large that understanding each other becomes difficult. So even if something is present, it might not interact in ways we can easily understand. And that could make detection even harder. Now imagine standing in a room filled with advanced technology you've never seen before. No labels, no instructions, just unfamiliar objects. You might not even recognize them as tools. You might think they are just part of the environment. In the same way, we might not recognize advanced signs if they don't match our expectations. And that leads to a quiet realization. The reason we haven't detected anything might not be because nothing is there. It might be because our way of looking is still limited, still growing, still learning. So when we look into the sky and see silence, it might not be empty silence. It might be a silence filled with signals we haven't learned to hear yet, patterns we haven't learned to read. And as that thought settles, another question begins to form. If something is out there, and if it chooses not to reveal itself, could that silence be intentional, a choice to watch, but not to be seen? If silence can exist even when something is present, then another idea begins to form. What if the silence is not an accident? What if it is a choice? A decision made by something more advanced to remain hidden? This idea is often described in a simple way. Imagine Earth as part of a kind of cosmic zoo, not a place where animals are kept behind bars, but a place that is observed, protected, left alone. So then, the question becomes, why would anyone choose to do that? To understand this, it helps to think about how humans observe life on Earth. When scientists study animals in the wild, they often try to avoid being noticed. They use hidden cameras. They watch from a distance. They stay quiet, because the moment the animal becomes aware of them, its behavior changes. It becomes cautious, alert, different. So if the goal is to understand natural behavior, the best approach is to observe without interfering. Now imagine applying that idea on a much larger scale. A civilization looking at Earth might see a developing world, a place where life has grown, changed, and become more complex over time. A place where intelligence has emerged, but is still evolving. From their perspective, we might appear like a species in progress, learning, exploring, making mistakes, growing. And that might raise a question for them. Should we interact, or should we observe? Because interaction changes things. Even a small contact could alter the course of development. It could influence decisions, beliefs, technologies. It could shape the future in ways that are difficult to predict. So perhaps the safest choice, the most careful approach, is to remain hidden, to watch quietly, to let things unfold naturally. This is the core of the idea. Not that we are being controlled, not that we are being watched in a direct or intrusive way, but that we might be part of a larger observation, one that avoids interference. Now here's a gentle question. If that were true, would there be any signs? Or would everything appear completely normal? If observers are careful, there might be no obvious signs at all, no clear signals, no visible presence, just silence, because any noticeable action could reveal them. And once revealed, the observation changes, so remaining unseen becomes part of the process. It's like watching from behind a one-way mirror. You can see everything on the other side, but those being observed cannot see you. Now consider something else. If there are many civilizations in the universe, each at different stages of development, there might be a kind of understanding, an agreement, a shared approach, not to interfere with younger or developing worlds, to allow them to grow on their own, to reach their own discoveries, their own understanding. This idea sometimes feels similar to a simple rule. Do not interfere. Let them learn. Let them find their own path, because growth often depends on experience, on trial and error, on making choices without outside influence. So, if a more advanced civilization sees Earth, they might decide to step back, to observe, but not to guide, not to reveal themselves. And that leads to another thought. From their perspective, time might feel different. What seems like a long time to us, decades, centuries, might feel short to them, so waiting is not a problem. Observation over long periods is not difficult. They could watch humanity develop over thousands of years, the same way we might watch a slow process unfold, patiently, without urgency. And that patience makes quiet observation possible. Now here's a common belief that often appears. Some people imagine that if aliens exist, they would want to make contact immediately, to communicate, to share knowledge, but that assumes that contact is always beneficial. What if it's not? What if early contact could cause confusion, fear, dependence? What if it changes the natural path of development? So instead of reaching out, they might choose to wait, to observe until a certain point, until a civilization reaches a level where contact becomes meaningful or safe. And that raises another quiet question. What would that point look like? Would it be technological advancement, a certain level of understanding, a change in behavior? It's difficult to say, because we don't know what criteria they might use. But the idea itself suggests that observation could be ongoing, without interaction, without clear signs. Now imagine this for a moment. Earth, moving through space, life evolving, civilizations rising and falling. All while, somewhere beyond our awareness, something is watching, not judging, not interfering, just observing, like a quiet presence. And if that is the case, then the silence we experience might not be emptiness, it might be restraint, a decision to remain unseen, to allow us to continue as we are. And that leads to a final, gentle thought. If someone is watching us in this way, not interfering, not revealing themselves, then perhaps the most important question is not whether they are there, but whether we would ever know, unless they chose to let us see them. If the idea of quiet observation feels possible, then it naturally leads to another gentle thought. What if it's not just a choice made by one civilization? What if it's a kind of rule, not a law written anywhere we can see, but a shared understanding? A guideline that more advanced civilizations might follow when they encounter a developing world like Earth. The idea is simple. Do not interfere. Let the world grow on its own. At first, this might feel familiar because even here on Earth, we follow similar ideas in certain situations. When studying nature, we try not to disturb it. When observing a fragile environment, we take care not to change it. Because once you interfere, the original state is lost and you can never fully return it to what it was. So now imagine applying that idea to an entire planet, a world with billions of people, each living their own lives, making decisions, learning, adapting. If something much more advanced were to suddenly appear, everything would change. Not just technology, but beliefs, culture, the way people see themselves in the universe. It would be like opening a door to something so unexpected that it reshapes everything at once. So then the question becomes, is it better to make contact or to wait? If the goal is to allow a civilization to develop naturally, then waiting might be the better choice. Because discovery has its own value. Learning something on your own, step by step, creates understanding in a way that instant knowledge cannot. It's like solving a puzzle. If someone gives you the answer immediately, you know the result, but you miss the process. You miss the journey. And the journey is where growth happens. So perhaps, from the perspective of a more advanced civilization, Earth is still in that process, still learning, still exploring, still asking questions, and interfering too early might interrupt that. Now here's a gentle question. What would interference actually mean in this context? It doesn't have to be something dramatic. Even a small sign could have a large effect. A clear signal, a visible presence, a piece of advanced technology introduced too soon. Any of these could change the direction of development, because once something new appears, it becomes part of the system. It influences decisions. It shapes future choices. So avoiding interference might mean avoiding any action that could be noticed, remaining completely hidden, allowing everything to continue without disruption. And that leads to another thought. If such a rule exists, It might not be about control. It might be about respect for the natural development of a civilization, respect for its ability to grow, to learn, to make its own path, because each world might be different. Each one might develop in its own unique way, and that uniqueness could be valuable, something worth preserving. Now imagine for a moment a young civilization discovering the stars for the first time, building its first telescopes, sending its first signals, asking its first questions about life beyond its own planet. From an outside perspective, that moment might be important, a kind of early stage, and interfering at that stage might change everything that follows. So instead, an observer might choose to wait, to watch quietly, to see how things unfold. Now here's something interesting to consider. If multiple civilizations exist, they might all follow similar ideas, not necessarily because they agreed together, but because they reached the same conclusion, that non-interference is the safest, most careful approach. It's like different people arriving at the same answer independently, through experience, through understanding. So this rule might not be enforced. It might simply be understood, a shared way of thinking. And that could explain why we haven't seen clear signs, because if everyone follows the same approach, then no one reveals themselves. Now here's a common belief that sometimes appears. People often think that if advanced beings exist, they would want to help, to guide, to share knowledge. But help can be complicated, because what seems helpful from one perspective might create problems from another. Giving advanced technology to a developing civilization could lead to rapid change, but not all change is stable. Not all change is easy to manage. So instead of helping directly, they might choose to let the civilization grow into that knowledge on its own, at its own pace. And that brings up another quiet question. When would it be the right time to make contact? If there is such a rule, there might also be a moment when it no longer applies, a point where a civilization has reached a certain level of understanding, a level where contact would not disrupt, but expand, where the meeting becomes a continuation of growth, rather than a sudden interruption. But what that point looks like is unknown. It might not be based on technology alone. It might involve awareness, stability, or something else entirely. And from our perspective, it's difficult to know where we stand. Are we close to that point, or still far from it? That uncertainty leaves the question open, but it also creates a sense of quiet patience. Because if observation is happening, if non-interference is being followed, then the silence we experience might not be emptiness. It might be waiting for the right moment, waiting for the right conditions. And as that thought settles, another idea begins to form. If civilizations choose not to reveal themselves, not just to avoid interference, could there be another reason, a deeper one, that makes staying hidden the safest choice of all? If silence can be a choice, and if waiting can be intentional, then another, deeper possibility begins to take shape. Not a peaceful one, but still calm in its own way. What if civilizations stay quiet, not just to protect others, but to protect themselves? This idea is often described in a simple way. Imagine a vast, dark forest. You are walking through it at night. You cannot see very far. You don't know what else might be out there. Other beings could be nearby, but you have no way of knowing their intentions. Are they friendly? Are they dangerous? There is no clear answer. So what do? Do you call out, hoping for a response, or do you stay silent to avoid being noticed? Most people in that situation would choose silence, not because they know something is wrong, but because they don't know, and uncertainty can be enough. Now imagine that same idea, but on the scale of the universe. Each civilization is like someone in that dark forest. alone in their own region, aware that others might exist, but unsure of who they are or what they might do. So then the question becomes, is it safer to reveal yourself or to remain hidden? If you reveal yourself, you send a signal, you announce your presence, and that signal travels outward. Anyone listening could detect it, but you don't know who is listening, you don't know their intentions, and you don't know how they might respond. So revealing yourself carries risk. Now here's a gentle question. What kind of risk? It doesn't have to be immediate or obvious. It could be something slow, something distant, something that unfolds over time. Because in a universe this large, even small possibilities can matter. So from a cautious point of view, silence might feel safer. Not because danger is certain, but because it cannot be ruled out. And when the stakes are high, even a small uncertainty can influence behavior. Now think about this in a simple way. If you were in that dark forest and you heard a sound in the distance, would you immediately move toward it? Or would you pause? Listen carefully. Stay quiet. Most likely, you would be cautious. You would want to understand more before acting, and that same logic could apply to civilizations. So instead of broadcasting loudly, instead of sending strong, obvious signals, they might choose to remain quiet, to observe from a distance, to avoid drawing attention, and that could explain something important. Why the universe feels silent, not empty, but quiet. Now here's a common belief that often appears. People sometimes think that advanced civilizations would naturally be peaceful, that with more knowledge comes more understanding. And that might be true, but it's also possible that not all civilizations are the same, just as life on Earth shows a wide range of behaviors. From cooperative to competitive, the same could exist elsewhere. And without knowing who is out there, caution becomes a reasonable choice. Now imagine this for a moment. A civilization detects a signal from another world. A faint pattern, something structured, something artificial. What do? Do they respond immediately? Or do they observe first, study, learn, wait? Because responding reveals something. It shows that you are there, that you are capable, and once that information is shared, it cannot be taken back, so perhaps the safest approach is to remain silent. To gather information without revealing your own position. Now here's another thought. If many civilizations follow this kind of thinking, then the result would be a universe where everyone is listening, but no one is speaking. A quiet network of observers, each one aware that others might exist, but choosing not to announce themselves. And that silence could last for a very long time. Now consider something else. Even if a civilization decides to send signals, they might do so carefully, directed, limited, not broadcast in all directions. So unless you are in the exact path of that signal, you might never detect it. It's like shining a flashlight in a specific direction. Anyone outside that beam sees nothing. So communication might still be happening, just not in ways we can easily notice. And that leads to another question. Where does Earth fit into this picture? Because we have been sending signals, not intentionally as a message, but as a byproduct of our technology. Radio, television, radio, all of it leaking into space. So in a way, we have already made ourselves visible, not loudly, but enough to be noticed. And that raises a quiet thought. If someone out there follows this cautious approach, if they see our signals, what would they do? Would they respond? Or would they stay silent, observing, learning, waiting? Because from their perspective, we are still unknown, still uncertain, and that uncertainty might be enough to keep them quiet. Now, this idea doesn't mean that the universe is dangerous. It doesn't mean that something is watching with harmful intent. It simply suggests that caution might be common. That silence might be a natural result of not knowing. And that leads to a final, gentle thought. If civilizations choose to remain hidden, not because they cannot reach each other, but because they are careful, then the silence we experience might not be emptiness at all, but a quiet balance where everyone is listening and no one wants to speak first. If silence can come from caution, and if observation can happen without being noticed, then a simple but powerful idea begins to settle in. What if watching doesn't require any signal at all? No message, no reply, no clear sign, just quiet observation. At first, this might feel unusual. We often associate watching with interaction. If someone sees something interesting, they respond, they react, they engage, but that's not always necessary. In fact, sometimes the most complete form of observation is the one that leaves no trace. Think about how we watch certain events on Earth. A camera placed high above a city records everything below. Traffic moving, lights turning on and off, people going about their day. The camera doesn't speak, it doesn't interfere, it simply records. And from that recording, someone can learn a great deal. Now imagine that idea extended far beyond Earth. An observer doesn't need to announce itself, it doesn't need to send a signal back. It only needs to receive, to collect information, to study patterns, and that can be done in complete silence. So then the question becomes, if someone were watching us silently, would we have any way of knowing? The answer most likely is no, because detection usually depends on interaction. We notice things that affect us, signals we receive, objects we can see, changes we can measure, but something that only observes, without emitting anything, might leave no clear trace. It's like someone reading a book in a dark room. The book is being observed, but the book has no awareness of the reader. No signal is sent, no sign is given. The observation exists, but it is one-sided. And that leads to a quiet thought. If observation can happen this way, then the absence of evidence doesn't necessarily mean absence of observation. It might simply mean that observation is passive. Now here's a gentle question. Why would someone choose to watch silently instead of interacting? The answer could be simple. Information, observation, without interaction, provides a clearer picture. It allows behavior to unfold naturally. It avoids influence. It avoids risk. Because once you interact, you become part of the system. You change it, even in small ways, and those changes can ripple outward. So if the goal is to understand, to study, to learn, then silence becomes a useful tool. Now imagine for a moment an observer watching Earth over a long period of time, decades, centuries, maybe even longer. They see patterns, growth, change. They observe how civilizations rise, how technology develops, how behavior shifts, all without ever revealing themselves. From their perspective, they might gather a deep understanding of humanity, not just from a single moment, but from many. A continuous flow of information, and that could be valuable. Now here's something interesting to consider. If they are watching silently, they might not need to focus on individuals. Instead, they might look at larger patterns, trends, movements, changes over time. It's like looking at a map of weather patterns. You don't track every single drop of rain. You observe the overall system, the direction of storms, the shifting of pressure. And from that, you understand how the system behaves. So an observer might see Earth in a similar way, not as billions of separate lives, but as a complex, evolving system. Now here's another question. Would silent observers ever choose to stop watching, or would they continue indefinitely? If the process is automated, or if time is not a limitation for them, they might continue for as long as they choose. Observation could be ongoing, continuous, without interruption, and that creates a quiet sense of presence. Not visible, not active in a way we can detect, but present in the act of observation. Now consider something else. If multiple observers exist, each one watching from different positions, then Earth might be observed from many angles, different perspectives, different distances, each one gathering its own data, and none of them needing to communicate with us directly. So from our point of view, everything appears silent, but from their point of view, Earth might be well understood. Now here's a common thought that sometimes appears. People often assume that if something is watching, it must eventually reveal itself. But that assumes that revealing itself is necessary. What if it's not? What if observation is the goal, and nothing more? Then there is no need to reveal anything, no need to interact, just to continue watching, quietly, patiently. Now imagine sitting by a window, watching the world outside. You don't need to step outside to observe. You don't need to speak, you simply watch, and in that quiet observation, you learn. So perhaps, if someone is watching Earth, it might feel something like that. A distant awareness, a steady attention, without interruption, without announcement, and that leads to a final, gentle thought. If observation can happen silently, without signals, without interaction, then the real question may not be whether we have detected anything, but whether detection is even possible. When the observer chooses to remain completely unseen, if observation can happen quietly, without signals or interaction, then another thought begins to form. What if signs are already there, but we simply don't recognize them? Not because they are hidden on purpose, but because they don't match what we expect. At first, it's natural to think that any sign of something unusual would be obvious, clear, easy to identify, but reality is often more subtle than that. Think about how people notice patterns in everyday life. If something fits what you already understand, you recognize it quickly. But if it doesn't, it can pass right by without being noticed. It's like hearing a word in a language you don't speak. The sound reaches your ears, but it doesn't register as meaning. It blends into the background. So then, could something similar be happening on a much larger scale? Could there be signals, patterns, or observations that we've already encountered but didn't understand? It's possible, because our ability to detect something depends not only on our tools, but on our expectations. We look for signals that resemble our own, structured radio waves, repeating patterns, something that stands out clearly from natural noise. But what if something exists outside that pattern, something that doesn't repeat in a simple way, something that changes, shifts, or behaves differently? It might not immediately appear meaningful. Now here's a gentle question. Have there ever been signals that puzzled us? The answer is yes. From time to time, scientists detect unusual signals from space, short bursts, strange patterns, things that don't have an immediate explanation. Most of these are eventually understood. Natural sources, new types of cosmic activity, instrument effects, but in the moment, before they are explained, they can seem mysterious. Not because they are necessarily artificial, but because they are necessarily, and that moment of unfamiliarity is important, because it shows how easily something can appear unusual, simply because we don't yet understand it. Now imagine that something truly different exists, something not produced by natural processes, but also not structured in a way we recognize. It might not stand out clearly. It might look like noise, like randomness, and if it looks like noise, it might be ignored, filtered out, set aside, because in a universe full of signals, we need ways to decide what matters, and sometimes that means overlooking things that don't fit. Now think about this in a simple way. Imagine you're searching for a specific shape in a large field of objects. Circles, squares, triangles. You're told to look for a square, so you focus on that. Anything that doesn't look like a square, you ignore. But what if the object you're looking for isn't a square at all? What if it's something completely different? You might look right at it and still not recognize it, because it doesn't match your expectation, and that idea can apply to how we search the universe. We are looking for familiar patterns, but the unfamiliar ones might pass by unnoticed. Now here's another thought. Not all signs need to be signals. Some could be physical, objects, structures, things that behave in unusual ways. But again, if they don't match what we expect, they might not be recognized. For example, an object moving in a way that seems slightly different from natural bodies. Not dramatically different, just enough to be unusual. Would we immediately recognize it as something artificial, or would we look for a natural explanation first? Most likely, we would try to explain it using what we already know, because that's how understanding grows. We start with familiar ideas and only move beyond them when necessary. So something truly unfamiliar might remain unexplained for a long time, not because it's invisible, but because it doesn't fit into our current understanding. Now here's a gentle question. Are we limited by our own perspective? In many ways, yes, because everything we know is based on our experience, our environment, our way of thinking. So when we look outward, we carry those assumptions with us, and those assumptions shape what we notice, what we recognize, what we understand. But the universe might not follow those same patterns. It might be more varied, more unexpected. So signs, if they exist, might not appear in ways we are ready to see. Now imagine this for a moment. Something is present, something is observable, but it doesn't look like a signal. It doesn't look like a spacecraft. It doesn't behave in a way that clearly stands out. Instead, it appears ordinary, part of the background, and because of that, it remains unnoticed, not hidden, just unrecognized. And that leads to a quiet realization. The boundary between nothing and something is not always clear. Sometimes it depends on understanding, on interpretation, on perspective. So when we say we haven't found anything, it might mean we haven't found anything we recognize, anything that fits our expectations. But beyond those expectations, there may still be possibilities, still questions, still things waiting to be understood. And as that thought settles gently, another question begins to form. If signs can exist without being recognized, if signals can pass unnoticed, if observation can happen silently, then what if the limitation is not what is out there, but what we are capable of detecting at all? If signs can be present without being recognized, then the next question becomes quietly important. What are the limits of what we can actually detect? Because everything we've talked about, signals, light, patterns, even possible observers, depends on one thing: our ability to notice them. And that ability, while impressive, is still limited. To understand this, imagine standing in a completely dark room with a small flashlight. You turn it on and look around. Where the light shines, you can see clearly, but everything outside that beam remains hidden. It doesn't disappear. It's still there. You just can't see it. Our technology works in a similar way. We use telescopes, sensors, and instruments to light up small parts of the universe, but we can't observe everything at once. We can't detect every kind of signal. We are always looking through a narrow window. Now here's a gentle question. What exactly are we able to detect? We can see certain kinds of light, The light our eyes can perceive is only a small part of a much larger range. Beyond that, we use instruments to detect other forms, like infrared or radio waves. But even with those tools, we are still covering only parts of the full picture. It's like listening to music through a radio that can only tune into a few stations. There may be many more signals out there, but if your radio can't receive them, you won't hear them. And that leads to an important thought. If something exists outside the ranges we can detect, we would have no direct way of knowing. Now think about signals. We often search for radio waves because that's a form of communication we understand. It's something we use, something we know how to detect. But what if another civilization uses something completely different? Something we haven't discovered yet, something that doesn't behave like radio waves at all. In that case, their signals could pass right by us without being noticed, not because they are weak, but because we are not tuned to them. Now imagine trying to listen for sound using only your eyes. No matter how loud the sound is, you won't perceive it because you're using the wrong sense. In the same way, if we are using the wrong methods, we might miss entire categories of information. Now here's another thought. Even within the ranges we can detect, there are limits. Sensitivity, resolution, clarity. For example, when we observe distant planets, they often appear as tiny points of light. We can detect them. We can measure certain properties, but we cannot see fine details. It's like looking at a city from very far away. You can see that something is there, but you can't see individual buildings. So even if something unusual exists on a distant world, we might not have the resolution to notice it clearly. Now bring that idea closer. Even within our own solar system, there are objects that are difficult to detect. Small, dark, distant. They reflect very little light. They move slowly. They blend into the background. So something could exist there and remain unnoticed simply because it is hard to see. Now here's a gentle question. How much of space have we actually explored in detail? The answer is very little. We have studied many areas, mapped many regions, but compared to the full size of space, our exploration is still limited. It's like exploring a vast ocean by sampling only a few areas. You learn something, but you don't see everything. And that means there are still unknowns, still gaps, still places where something could exist without being detected. Now consider something else. Detection is not just about seeing something. It's about recognizing it, understanding it, because even if we detect something unusual, we might not immediately know what it is. We might classify it as natural, or unexplained, or simply noise, until we gather more information. So detection is a process, not a single moment. And that process can take time, sometimes a long time. Now here's another thought. Our technology is always improving. Each new instrument expands our ability to observe. We see more, we detect more, we understand more, but that also means that what we cannot detect today might become visible in the future. So the limits we have now are not permanent, they are temporary. And as they change, our view of the universe changes with them. Now imagine this for a moment. Something exists just beyond our current limits, just outside the range of what we can detect. Not invisible, just slightly out of reach. As our tools improve, we get closer to seeing it, closer to understanding it. But for now, it remains hidden, not by intention, but by limitation, and that leads to a quiet realization. The universe is not just what we can see. It is also everything we cannot yet see, everything beyond our current reach. So when we ask, have we detected anything? The answer depends on what we are capable of detecting. And that capability is still growing, still expanding, still learning. And as that thought settles gently, another question begins to form. If something is out there, and if it communicates in ways we cannot yet understand, then what if the signals are already around us, but we simply don't know how to interpret them? If our ability to detect is limited, then another quiet possibility begins to take shape. What if communication is already happening, but we simply don't understand it? Not because it's hidden, not because it's weak, but because it doesn't look like what we expect. When we think of communication, we often imagine something familiar. Words, sounds, signals that repeat in clear patterns. Something that can be translated, decoded, understood. But that idea is shaped by human experience, by the way we communicate with each other. And there's no guarantee that something entirely different would follow the same approach. So then the question becomes, what could communication look like if it didn't resemble anything we know? To explore that, it helps to think about how different communication can be. Even here on Earth, humans use language, spoken words, written symbols. But animals communicate in very different ways. Some use sound, some use movement, some use chemical signals. For example, certain insects release tiny chemical traces that others can detect. To them, it carries meaning, but to us, it's invisible. We don't notice it unless we have the right tools. So even on one planet, communication can exist in forms that are completely unfamiliar. Now imagine extending that idea beyond Earth. A completely different environment, a completely different form of life. It's possible that their way of communicating might not involve sound or radio waves at all. It might use something we haven't even discovered yet, or something we can detect but don't recognize as meaningful. Now, here's a gentle question. If a signal doesn't look structured to us, does that mean it has no meaning? Not necessarily, because structure depends on perspective. What looks random at first might actually contain patterns we don't yet understand. It's like looking at a page filled with unfamiliar symbols. At first, it looks like noise, but once you learn the language, patterns begin to appear. Meaning begins to emerge. So a signal from another civilization might seem random until we learn how to read it. Now think about this in a simple way. Imagine hearing a piece of music from a culture you've never encountered before. The rhythm is different. The sounds are unfamiliar. At first, it might seem chaotic, but over time, you begin to notice patterns, repetition, structure, and eventually, it starts to make sense. Communication could work in a similar way. At first, it might seem like noise, but hidden within it, there could be meaning. Now here's another thought. What if communication doesn't rely on sending signals outward at all? What if it exists in forms that are not meant to travel across space in the way we expect? For example, it could be embedded in patterns of energy, changes in light, or interactions we haven't yet learned to interpret. Something subtle, something continuous, something that doesn't stand out as a clear message. In that case, we might already be surrounded by information without realizing it. Now consider something else. Even when we detect signals, we often look for repetition, regular patterns, because repetition suggests intention. But what if a signal is not repetitive? What if it changes constantly, adapts, evolves? It might not match the patterns we're searching for, so we might overlook it. Now here's a gentle question. Have we ever misunderstood communication before? The answer is yes. Even between humans, misunderstandings happen. Languages differ, meanings shift, context matters, and sometimes it takes time to understand what is being said. Now imagine that challenge multiplied across entirely different forms of life, different senses, different ways of thinking, different ways of expressing information. The gap could be much larger. So communication might exist, but understanding it could take time, patience, new ways of thinking. Now here's another idea. What if communication is not meant for us at all? What if signals are being exchanged between other civilizations using methods we cannot detect or interpret? In that case, the universe might be full of communication, but we are simply not part of that network yet. It's like walking into a room where people are speaking a language you don't know. Conversations are happening all around you, but to you, it sounds like background noise. Now imagine learning that language. Suddenly, everything changes. What once seemed like noise becomes meaningful. And that shift in understanding opens a new perspective. So perhaps, if communication exists beyond our current understanding, we are still in the early stages, still learning how to listen, still discovering how to interpret. And that leads to a quiet realization. The challenge might not be finding signals, but recognizing them, understanding them, seeing patterns where we currently see randomness. And as that thought settles gently, another question begins to form. If communication can exist in ways we don't understand, if signals can be present without being recognized, then what if something even more advanced exists? Something that doesn't just hide its signals, but leaves no detectable trace at all. If communication can exist beyond our understanding, then another quiet idea begins to form. What if something can exist and still leave no trace at all? Not because it is hiding in the way we imagine, not because it is actively avoiding us, but because it operates in a way that simply doesn't appear within our view. At first, that might feel difficult to imagine. We tend to think that anything real must leave some kind of sign, a signal, a reflection, a movement, something we can detect. But that assumption comes from how our own world works, from the limits of our senses, and those limits are narrow compared to what might be possible. So then the question becomes, what would it mean for something to be effectively invisible? It doesn't have to mean completely undetectable in every sense. It might simply mean undetectable to us, undetectable with the tools we currently have, undetectable within the ranges we are able to observe. To picture this, imagine a creature that can only see a small range of colors. To that creature, anything outside that range doesn't exist. It's not hidden. It's simply beyond perception. Now imagine extending that idea to technology. If a civilization becomes advanced enough, it might learn how to operate outside the ranges we detect, not by trying to hide, but by becoming more efficient, more subtle. Think about how human technology has evolved. Early machines were large, loud, and easy to detect. They used a lot of energy. They produced heat, sound, and visible motion. But as technology improves, it becomes smaller, quieter, more efficient, less waste. A modern device can do far more than an older one while using less energy and producing less noise. So if that trend continues, if a civilization advances far beyond us, their systems might become so efficient that they produce almost no detectable signals. Very little heat, very little energy loss, very little emission, and that could make them extremely difficult to notice. Now here's a gentle question. If something produces no excess energy, no obvious signal, and no visible movement, how would we detect it? The answer is, it becomes very difficult, because most of our detection methods rely on those things. We look for light, for heat, for signals, for changes in motion, but if something minimizes all of those, it blends into the background. Now imagine this in a simple way. You're in a room filled with quiet, still objects. Everything is calm. Nothing stands out. Now place something in that room that behaves exactly like everything else. Same temperature, same appearance, same motion, or lack of motion. You wouldn't notice it, not because it's hidden, but because it doesn't differ from its surroundings, and detection often depends on difference. We notice what stands out, what changes, what breaks the pattern. But if something matches the pattern perfectly, it disappears into it. Now consider something else. An advanced civilization might not rely on physical structures in the way we do. We build large things, cities, satellites, machines that occupy space, but what if they don't need that? What if their systems are compact, distributed, operating in ways that don't require large, visible forms? It's possible that their presence wouldn't look like anything we recognize. Now here's another thought. What if they don't exist in the same physical form we expect? Not necessarily something mysterious, but simply different, operating in environments or states we don't typically consider. For example, using forms of energy or matter that we haven't learned to detect clearly. In that case, they wouldn't be hiding, they would just be outside our frame of reference. Now here's a common belief that often appears. People imagine advanced civilizations as being more visible, more powerful, more noticeable. But what if the opposite is true? What if advancement leads to subtlety, to efficiency, to a kind of quiet presence that doesn't disturb the environment? It's like comparing a loud, bright flame to a small, steady glow. The flame is easy to see, the glow much less so. So perhaps if something is highly advanced, it might not stand out at all. Now imagine for a moment something existing in space, not sending signals, not producing excess heat, not reflecting light in unusual ways, not moving in a detectable pattern, just existing. From our perspective, it would appear as nothing, empty space, but in reality something could be there, operating in a way we cannot yet perceive, and that leads to a quiet realization. Invisibility does not always mean absence. It can simply mean beyond detection, beyond recognition, beyond our current understanding. So when we look into space and see nothing, it might not be truly empty. It might be filled with things we don't yet know how to see. And as that thought settles gently, another question begins to form. If something could observe us without being detected, if it could exist without leaving a trace, then what if it already knows everything about us? Not by interacting, but simply by watching and understanding over time. If observation can happen silently, if detection can be one-sided, then a quiet but powerful idea begins to form. What if someone already knows far more about us than we realize, not through contact, not through conversation, but through long, patient observation? Because if you watch something over time, you begin to understand it. Patterns appear, behavior becomes familiar, trends start to make sense. It's like watching the same place every day. At first, everything feels random, but slowly, you begin to notice routines, movements, changes that repeat, and from those patterns, you build an understanding. Now imagine that process applied to Earth. If someone has been observing our planet for a long time, they might have seen a great deal. Not every detail, not every moment, but enough to form a picture. They might have seen how our atmosphere changed over time, how our signals began, how our technology developed, how patterns of activity increased, and from that, they could begin to understand something important, that this is not just a living planet, but a changing one, a developing one. Now here's a gentle question. How much can you learn just by observing from a distance? The answer might be more than it seems. Even without direct contact, a lot of information can be gathered. For example, patterns of light can reveal how energy is used. Changes in signals can show technological progress. Variations in atmosphere can hint at activity, and over long periods, These small pieces of information add up. It's like reading a story one page at a time. At first, it's incomplete, but as more pages appear, the story becomes clearer. Now imagine that someone has been reading Earth's story for a very long time. Decades, centuries, maybe longer. They might have seen the early stages of human development, the rise of technology, the spread of communication. And as they observe these changes, they might begin to predict patterns, to anticipate what comes next. Now here's another thought. Understanding doesn't always require knowing everything. Sometimes, patterns are enough. For example, if you watch the weather, over time, you begin to recognize cycles. You don't need to know every detail of the atmosphere to understand the general pattern. In the same way, an observer might not know every detail about humanity, but they might understand the overall system, how it behaves, how it changes. Now consider something else. Our signals themselves carry information. Not just that we exist, but how we behave. Our broadcasts, our communication systems, our patterns of activity, they reveal structure, organization, complexity. And even if the content is not fully understood, the patterns are still there. So someone observing us might learn about our level of development, our growth, our changes over time. Now here's a gentle question. Could they understand us better than we expect? It's possible, because observation over long periods can reveal things that are not obvious in a single moment. It shows trends, shifts, long-term changes, and that kind of understanding can be deep, even without direct interaction. Now imagine watching a river flow. At first, it's just moving water, but over time, you begin to see how it changes, where it speeds up, where it slows down, how it shapes the land around it. And from that, you understand the system, but the behavior of the river as a whole. So perhaps, from a distant perspective, humanity might appear in a similar way, not as individuals, but as a collective pattern, a system that grows, changes, and evolves. Now here's another thought. If someone understands us through observation, they might not feel the need to interact, because they already have what they need. Information, understanding, interaction might not add much more. It might even disrupt the system they are observing. So remaining distant, silent, might be enough. Now consider something else. Time. If an observer is patient, time becomes an advantage. They can wait, watch, changes unfold, gather more information as it becomes available, so their understanding can continue to grow, without needing to rush, without needing to intervene. And that leads to a quiet realization. It's possible that observation alone could provide a deep level of understanding, enough to know that we exist, enough to understand how we behave, enough to recognize patterns in our development. Now here's a final gentle question for this moment. If someone already knows this much, if they have been watching, learning, understanding, then why remain silent? Why not reveal themselves? And that question leads into something deeper, because perhaps the silence is not just about observation, but about something else entirely. A choice that goes beyond curiosity, a choice that carries a different kind of meaning. If observation can be silent, if understanding can grow without contact, then one final thought begins to settle in, slowly and quietly. What if the silence is not a limitation, but a decision? Not because contact is impossible, not because no one is there, but because, for some reason, it is not chosen. At first, this idea might feel unsettling, but it doesn't need to be. It can be approached gently, like everything else we've explored. Because the question is not about fear, it's about possibility. So then, what would it mean if something out there knows we exist, understands us, and chooses to remain silent? To understand this It helps to return to something simple: choice. Every action, every decision comes from a reason. Sometimes that reason is clear, sometimes it isn't. So if silence is a choice, there could be many reasons behind it. Some we might understand, some we might not. Now here's a gentle question. What are the possible reasons for not making contact? One reason could be caution, not fear, but careful consideration. If interacting with a developing civilization could change it in unpredictable ways, then remaining silent might feel safer for both sides. Another reason could be timing. Perhaps there is a belief that contact should happen only at a certain stage. A moment when understanding is ready, when the interaction becomes meaningful instead of disruptive. So silence, in that case, is not permanent. It's temporary, a kind of waiting. Now imagine this in a simple way. A teacher watching a student solve a problem. The student struggles, makes mistakes, tries again. The teacher could step in immediately and give the answer, but instead, they wait, because the process of figuring it out matters. So the silence is not neglect, it's patience. Now here's another thought. Silence could also come from difference, a gap so large that interaction becomes difficult. Not impossible, but complicated. Imagine trying to explain something complex to someone who doesn't yet have the background to understand it. You might choose to wait, not because you don't want to communicate, but because the timing isn't right. Now here's a deeper question. What if the silence is not about us at all? What if it is about them? Their own rules, their own priorities, their own way of existing? Because we often assume that others would act the way we would, that they would want to explore, to connect, to communicate. But that assumption comes from our perspective. Their perspective might be different. Their goals might not include interaction. They might value observation more than communication, understanding more than contact, and that difference could shape their choices. Now here's something important to remember. Silence does not always carry a negative meaning. It can simply be neutral, a state of not acting, not interfering, not engaging. And in that stillness, there can be intention. Now imagine standing under the night sky, looking up at the stars. Everything feels quiet, still. But that quiet doesn't mean nothing is happening. Stars are burning, planets are moving. Light is traveling across unimaginable distances. The silence is not emptiness, it's just distance and perspective. So when we think about the possibility that someone might be watching and choosing not to reveal themselves, it doesn't have to feel threatening. It can simply be part of a larger system, a way of interacting or not interacting that we don't yet fully understand. Now here's a gentle question. Would we do the same if we discovered a distant planet with life, with a developing civilization? Would we immediately make contact? Or would we observe first, wait, learn, consider the consequences? Because once contact is made, it cannot be undone. It changes everything. So even for us, the decision might not be simple, and that makes the idea of silence feel more familiar, more understandable. Now imagine this final thought. Somewhere out there, an observer exists, not close, not visible, but aware. They have seen Earth, studied it, understood its patterns, and for now they choose to remain silent, not because they cannot reach us, not because they don't know we are here, but because, for reasons we may not yet understand, silence is the choice that makes the most sense. And here, on Earth, we continue, living, learning, exploring, sending signals into space without fully realizing how far they travel, looking outward, asking questions, wondering what might be out there. And perhaps in that quiet exchange, we are not just asking, we are also being observed, not in a way that interrupts, not in a way that reveals itself, but in a way that simply watches, patiently, silently. And as that thought gently settles, one final question remains. If someone is out there, watching, knowing, and choosing to remain silent, would we ever be ready for the moment when that silence ends?